In the world of digital manufacturing, whether it's the 3D printer humming away on your desk or a giant CNC mill carving metal in a factory, there's this invisible language pulling all the strings. It's the silent commander turning your digital ideas into real, physical things. Well, today, we're going to pull back the curtain and make that language visible. So, here's the big question, right? You've got this amazing design on your screen, this perfect 3D model, but how do you actually get a machine, a physical thing with motors and tools, to understand it and build it with absolute precision? How do you bridge that digital to physical gap? Well, the answer is a language, and it's called G-code. G-code, which stands for geometric code, is basically the universal translator between your design and the machine. Think of it like the most fundamental, stripped-down instruction manual you can imagine. Every single line is a super specific command telling the machine exactly where to go, how fast to get there, and the precise path it needs to take to make it happen. So let's dive in and actually see what this stuff looks like. Okay, so if you open up a G-code file for the first time, it can look, well, let's be honest, it looks like a wall of intimidating code. But once we peel back that first layer, you'll see it's really just built from a bunch of simple, logical instructions. And we're going to break one down right now. All right, check this out. This is one single, very typical line of G-code. I know, it might look like total nonsense, but this one little line contains everything a machine needs for one single precise movement. So what on earth is it actually saying? Let's break it down. That first part, G01, that's the main command. It's the action word. The G tells the machine we're about to do a general movement, and the 01 part specifically says, move in a perfectly straight line at the speed I'm about to give you. This command right here is the absolute workhorse of digital manufacturing.
Next up, you've got your X, Y, and Z values. And this is super straightforward. It's just a destination. It's like telling your car's GPS, I need to go to these exact coordinates on the map. The machine knows where it is, and this tells it exactly where it needs to go next in 3D space.
And that last piece of the puzzle, the F value, that's all about speed. F stands for feed rate, which is just the fancy way of saying how fast the machine should move while it's making that straight line trip to the coordinates we just gave it. So you see, when you put it all together, that scary line of code becomes a very simple sentence for the machine. Move in a straight line to this exact spot at this specific speed. That's it. Every mind-blowingly complex part you've ever seen is just built from thousands and thousands of these simple little sentences. Okay, so here's where it gets really, really interesting. This one single language, G-code, is the driving force behind two completely opposite ways of making things. You've got the world of adding material and the world of taking it away. Same language, totally different angles. Think about it. On one side, you have 3D printing. That's an additive process. The G-code is telling the machine where to go to lay down or deposit melted plastic, building an object up from nothing, one tiny layer at a time. Then you flip the script for CNC machining. It's Subtractive. Here, the G-code guides a sharp cutting tool to remove material from a solid block, carving away everything that's not your part. And this table really lays out the practical differences. For 3D printing, you use a slicer program to turn your model into G-code, and a really key command is the E value, which tells the machine exactly how much plastic to push out. For CNC, you use what's called CAM software, and a critical command is the M value, which does things like turn on the high-speed cutting spool. Now, these different goals and tools also lead to a completely different day-to-day experience for the actual user, the human in the loop. The way a hobbyist with a 3D printer thinks about G-code is a world away from how a professional CNC machinist does. In the 3D printing world, for most people, G-code is just this magical thing that happens in the background. As this person on Reddit says, the workflow is just beautiful and simple. You design something, you slice it, and you hit print. They've made hundreds of parts and have never, ever had to look at or edit a single line of code. But then you jump over to the CNC world, and wow, it is a completely different ballgame. This quote from a pro machinist shows a much more intense, hands-on relationship with G-code. For them, editing code right there on the machine isn't some problem to be avoided. It's a critical part of their daily job to get things just right. Which leads to the obvious question, right? If they're both using G-code, what gives? Why is one workflow so automated and hands-off, while the other requires you to get your hands dirty and manually edit the code? A huge part of the answer comes down to this one, kind of tricky little piece of software called the post processor. Think of it like a translator for different dialects. Your CAM software makes a generic set of cutting instructions, but the post processor's job is to translate that into the specific dialect of G code that your particular brand and model of CNC machine understands. And that's the key right there. Because every single machine can have its own little quirks and special commands, getting that final translation absolutely perfect is a huge challenge. This is exactly why CNC machinists need to jump in and manually tweak the code to fine-tune that translation or optimize a specific cut without having to regenerate the whole thing from scratch.
So this complexity in the CNC world, it's a major barrier for a lot of people. But what if we could flip the entire interaction on its head? The future might not be about us learning the machine's language, but about the machine learning ours. We're shifting from being a programmer to being a prompter.
Let's be real. The core problem has always been that writing G-code by hand is difficult and super easy to mess up. And while CAM software is a huge help, it can have a crazy steep learning curve and be really expensive. All of this just creates a massive barrier to entry. Well, to tackle this head-on, researchers are now developing some incredible new systems, like one called GLLM. It uses the same kind of AI that powers chatbots to generate all the complex G-code you need directly from simple, plain English instructions. It's a bridge between what you want to say and what the machine needs to hear. And this is where you can really see the magic happen. Just look at this. A user can literally just type a normal sentence like, create a 20mm radius circle 2 millimeters deep. The AI system figures out what that means and generates the perfect, error-free G-code to make it happen. All that complexity just gets handled for you. And all of this, it leaves us with a really fascinating kind of mind-bending question for the future. For decades, the skill was all about learning the machine's language. But as we head towards a future where the machines can finally understand our language, what's the new essential skill for making things? Maybe it's not about programming the path anymore, but about having the vision to clearly and creatively describe the destination.